If you woke up on the surface of this world, your brain would try to trick you. You would see river valleys carved into the ground, heavy clouds dumping rain onto a dark shoreline. You'd hear the wind howling through the hills. It looks like home, but it's the ultimate illusion. Because the rocks you're standing on, they aren't stone, they're frozen water, ice hard as granite. On Titan, water behaves like lava. It erupts from the ground, it freezes solid, it becomes the foundation of mountains, and the rain falling on your helmet isn't water, it's liquid methane, fuel falling from the sky. Methane clouds rise, condense, and fall just like rain on Earth. There are storms, seasons, coastlines, an entire weather system built from hydrocarbons instead of water. Welcome to Titan, the only moon with a thick atmosphere, and the only world besides Earth with stable liquid on its surface. Earth's toxic twin. For 40 years it was a mystery, wrapped in smog, until we dropped a robot into the clouds to see what was hiding underneath. In 2005, humanity did something audacious. We detached the Huygens probe from Cassini and sent it plummeting into Titan's atmosphere. It remains the most distant landing ever attempted by our species, over 750 million miles from Earth, with no chance to correct mistakes. As it fell, it didn't see stars. It didn't see Saturn. It saw only a thick, suffocating orange smog. A global haze made from complex organic molecules created when sunlight breaks apart methane high in the atmosphere. This haze is so dense, it hides the surface completely. Visible light can't penetrate it. If you orbited Titan with your naked eye, you would see nothing but a smooth orange sphere, but near the end of the descent, the haze cleared, and Huygens sent back this image. Look closely. Do you see those rounded stones? On Earth, river rocks get rounded by tumbling in water for thousands of years. On Titan, these are ice pebbles, rounded the same way, but by floods of liquid natural gas, methane rivers, methane rain, methane erosion. That photo proved Titan isn't just a distant orange ball. It's an active, flowing world, a place where chemistry doesn't just sit still. It moves. So, could anything live here? If you're looking for life as we know it, no, absolutely not. Titan is minus 290 degrees Fahrenheit. Coffee would freeze before it hit the ground. At that temperature, water is useless. Proteins shatter. DNA can't function. Every biological process we rely on simply breaks. But Titan forces a different question. What about life as we don't know it? Biologists have modeled a new kind of cell membrane, not made of fats, but made from Titan chemicals like acrylonitrile. On Earth, cell membranes form automatically in water. On Titan, these membranes could form in liquid methane, creating structures that behave like cells, but are chemically alien. If something exists in Titan's lakes, it wouldn't breathe oxygen. It might breathe hydrogen. It wouldn't drink water. It would drink fuel. That's the dream. But here's the problem. At minus 290 degrees, chemical reactions don't just slow down. They crawl. On Earth, life is fast. Cells divide. Enzymes work. Energy flows. On Titan, a reaction that takes 1 second on Earth might take 15 minutes on Titan. Energy is scarce. Movement is expensive. Evolution itself could take millions of times longer. Even if life exists, it might be immobile, metabolizing so slowly it would look like a rock to us. And there's a second problem. Methane is a terrible solvent. Water dissolves salts, sugars, amino acids, the building blocks life needs. Methane, it dissolves almost nothing. Chemistry needs interaction. And Titan's liquids keep molecules isolated, locked away from each other, so even if Titan has the ingredients for life, it might not have the kitchen. And that's the paradox of Titan. It has everything life needs, except the one thing life can't live without: energy. Which is why we have to go back. NASA is building the Dragonfly mission, and it is a beast. A nuclear-powered octocopter, roughly the size of a Mars rover. This isn't a lander, it's not an orbiter, it's a flying laboratory. Why a drone? Because Titan is the easiest place in the solar system to fly. Low gravity, and air thicker than Earth's. The atmosphere does most of the work for you. Rotors barely need to spin. You could strap wings to your arms and fly on Titan like a bird. Dragonfly will land again and again, hopping dozens of miles at a time, drilling and sampling, using instruments designed to taste the chemistry of Titan's sands. It will analyze carbon chains, search for prebiotic chemistry, and test whether Titan's environment can actually support complexity or just fake it. Its target launch is July 2028. There's one final twist to Titan, a prediction that spans billions of years. One day the sun will expand, Earth's oceans will evaporate, and our planet will end. But as the habitable zone moves outward, Titan thaws. Its ice shell could melt into liquid water. Methane boils away. Carbon chemistry gives way to water chemistry. And for a brief window, maybe only a few million years, Titan could become the most habitable paradise in the solar system. A warm ocean world, with organic material preloaded by billions of years of chemical experiments. A second chance for life, waiting in the deep freeze until the universe turns the thermostat up. So where does that leave us? We've looked at super-Earths, eyeball planets, buried oceans, and now a methane moon pretending to be Earth. Each world offers hope, each one offers horror. It's time to stop exploring and start deciding. If humanity had the budget to send a flagship mission to only one of these worlds, which one actually deserves it? I've ranked them, and the winner is not the one you expect.